to cloud. And then we are going to start our today's.
I have a question.
Yeah, please.
I noticed that it says we need to submit a zip file with all of our submitted files. If it's all in one notebook, does it need to be zipped still, even though it's just one file?
Yeah, that's, I set default as zip, because if you don't zip it, then it won't take the file. I believe that's what going to be, is it?
But it's okay that we're submitting one, that there's just one file inside the zip file.
Yeah, that's okay.
Okay.
Yeah. Maybe, I don't know, because I don't know how to make it consistent, because some other students, they may send some other file formatting, and maybe I don't know. So that's why I say, okay, how about just put a zip file? Or if you guys have any other good recommendations, then maybe later on we can change it to other file formatting. Which file formatting you all, or most of you prefer?
I thought we were just going to be using Jupyter Notebook.
Yeah, we are supposed to just use Jupyter Notebook. So how about I just set it to Jupyter Notebook file format? But the question is, I don't know if Canvas allows that, because that's not a common file formatting.
But if it was a file writing and reading, we need to add some files also, right?
Pardon me?
If it was any file writing or like that assignment, we need to attach .csv files also, right?
Oh, yeah, you're right. Yeah, later on when we have CSV file, yeah, you also need to attach a CSV file. So we still need to have a zip file. Yeah, right now it's okay, because right now we don't have the CSV file. Logan says a note. Hold on, okay, let me see what Logan said. That was for showing the output. Canvas support any file formatting. Okay, I will double check that. Okay, the output. A screenshot, we don't need a screenshot here, because Jupyter Notebook, anyway, we can have the running result, is it? So you don't need to submit a screenshot, okay, here. So if you just submit that Jupyter Notebook with the running result, that's fine, okay, that's fine. Okay, and do you think we just keep a zip file will be okay with everyone?
I think that's fine. I was just a little confused because my zip file only had one file, but if it's because you want to be able to have
right now,
.py.
Yeah, you're right. Yeah, right now we do have this situation, just a single file. But later on, you also need to submit the CS of some other file. So it's going to be multiple files. Yeah, some student just reminded me. Yeah, thanks.
Okay.
Thanks a lot. Yeah. Okay, so temporary, let's just keep a zip file. Okay.
Yeah.
Then I think I already recording. Yeah, so we are going to start. So I'm going to share screen first. So what we will do today, we will move to new topic, okay, about a new package, Numpy package, okay. Let me change the Numpy package. So it's regarding array and vectorized computation. You will see it's very powerful, okay. Kind of, I cannot, I need to. Okay, and Numpy, just give you some very general information. Numpy is basically for numerical, okay? So that's why I said it's a package, Python for scientific computing, okay, for scientific computing. And it supports very large and multi-dimensional array and matrix calculation, okay? And it's also said it's much faster if you compare it, if you want to do it in Python list, okay, list. So it's faster, but there is a major difference is if you record list supports a hierarchical, is it data type, multiple data type, is it? But NumPy array, it's not. It's just support one type. It's for numeric, it's a scientific, mostly for numeric computing, is it? So that's why. And it's for scientific computing. Okay, so that's a major. Its major feature is a large and multi-dimensional array and matrix calculation. So regarding that, it has the advantage. Okay, and it's also the base. Later on, we will also see. Okay. For some package like SciPy, sklearn. Sklearn is mostly for machine learning. Okay, so machine learning is based on math, so that's why it's based. You also need to do some data conversion. Okay, and convert to NumPy array. Okay, that's NumPy general information, the basics. As I said, NumPy-based algorithm, what it says generally 10 to 100 times faster, okay, than the pure Python counterparts. And also it uses less memory, okay. And it's create the array, it's not just called array, it's called ND array, okay. I believe it's represent n-dimensional array, okay. And they said the easiest way, later on we will see in our note, is to use the array function, okay? And the constructor basically takes any sequence-like object. Sequence we already learned, is it list, tuple, is it those from Python. Okay, so that's some just general concept question. Let's see, okay, over here. It says it can also explicitly convert or cast array from one. And in NumPy array, we call it D type, okay, to another ND array type, okay. So that's why, and also it says calling S type. So S type can always be careful here to create a new array, okay. So it's a copy of the array. Okay, it's copy. So basically over here it means a deep copy. Okay. And also later on we will see on the notes. So this is kind of like it's called broadcast rule. Okay. So any arithmetic operation between equal size array applies the element wise. Okay, this is kind of like math. You have some matrix operations that's also element wise, but not all of that. Okay. And also it says comparing between different array, between array of the same size, going to generate, we also have some array called Boolean array, okay, over here. And later on we will see that. We will see this in our example. So next, let's go back to the example. I need to bring that up. Okay, here. Okay, so let's take a look at the note. And this is the first note. And this first note is from NumPy Quick Start, okay, official website. So if you want, you can also find it. But I may here and there add a little bit of my own stuff. And in order to use, in our slides, we already say, okay, NumPy array. The class is called ND array, okay, ND array, so be careful here. And if you want to use NumPy, you need to import its package. And generally speaking, a lot of time we do import NumPy as MP, okay? It's not mandatory as MP, you can name some other, but that's normally what we do, MP. And then this is a constructor to build the ND array, okay? And with what? This is a list, Python list, is it? So you can use 2, 3, 4, this list to create a NumPy array, okay, NumPy array. And what it looks like here, okay? Array and then parentheses and list the items. So this is NumPy array A, is it? And the B is also a NumPy array, is it? And with a list you create. And you can also get to the shape, is it? So this shape, because, hold on, I have 2 students. Need to admit both of them. And over here, the shape, the first dimension is 3, is it? And we don't have other dimensions, is it? So that's what this information tells us, the shape. Later on, we will also see the shape also quite useful, okay? When you do machine learning, you also want to know that. And then let's see here. This ND array constructor, is it? Over here, I pass in what? A list with 2 tuples. Anyway, so this is also Python sequence, is it? So then this is going to create what? A 2-dimensional array. So this is a 2-dimensional NumPy array. Is it what it looks like? Be careful here, okay? You have 1 brackets, is it? And then you have second level of brackets, is it? And so you have 2 level of brackets. So this is a 2-dimensional, okay? And the next one, we are not going to use that a lot, okay? This is for complex data type. Okay, if you want, you can also specify something like this and create the complex data type. And then next, let's see. So with NumPy, it also can generate the range of number. Okay, then the name is called aRange function. Okay, and you call np.aRange. It has a starting number, ending number, but it's exclusive. Okay, not included, the one. And you can specify the step. And what it returns, be careful, it returns array, okay? This gives you an array. So its starting number is 10, and at 30, is less than 30, every 5 number. So that's why you have 10, 5, 20, 25, but not including 30, okay? 30 is excluded. And this is an array, is it? And you can also generate between 0 to 2 every 0.3. So this is what this arrange method. And you can also generate number, sequence of number, use another function called linspace. Okay, linspace, it's a little bit different from the arrange. Arrange, you need to know the step. But a lot of time you may just know a range of number and you know how many number you want to generate. Is it? You don't know the step. Then in this case, you can specify, is it the starting and the ending and the number of items. And it's also going to be an array. In this case, this end is included. If you take a close look here, is it? It's included. Okay, that is what this example shows. Nice. It can also be used to create an array. Okay, so we have learned a couple of ways to create an array. So what next it shows just, so this is a range of number items from 0 to 2 pi, is it? And with 100 numbers, is it? And if you take a close look of what the next line shows is, this is basically the math sign, is it? The sign. Take the sign using what? Using this array, is it? And here, if you take a look, in NumPy, what's going to be F? So here is a question. So how about this going to be our first quiz question? Quiz question. So F is going to be a single number. So what's your guess? It's going to be single number or some sequence? Or the ND array. So NumPy array.
It's NumPy array.
Yes, very good. Okay, it's a NumPy array. Okay. So this F is going to be NumPy array. Okay, it's not a sequence. But did you see here? We didn't use any loop. No loop involved. Is it? And if you recall in the previous units that what we learned with a sequence, if you have sequence of items, and suppose you want to generate sign of the sequence of numbers. So it's a sequence, Python sequence. Python sequence. How do we do that without a loop? So how about this is a second quiz question. Who still, no, suppose you are not going to use a loop, just use a single statement. Just use some single statement. How can we do that? How can we achieve that? Who still remembers?
List comprehension?
Yes, yes. Is it? Yeah, you can do list comprehension. Is it? So list comprehension, it's still, if you compare with this formatting, which is more concise. This is so much concise. Is it so much concise? That's because what I believe is NumPy is heavily relied on math. Is it numeric like a matrix operation? Is it? So in math, very abstract level, you can also do something like this. Is it? Suppose this X is just some, some vector. Is it? It can represent some vector. Is it? Then you can do just something like that, like sign. Is it? So I believe that's a concept to come from. Okay, but anyway, in Python, if you got to use a list comprehension or what we call the generator, is it concept? So generator expression is, if you recall, you can also do that. Is it? Anyway, so but with NumPy, then you see we don't need to worry that anymore. This is so good. Is it? But of course, NumPy has its limitations, not for all kinds of data types. So that's why Python's list comprehension and generator expression still has their benefits regarding if you want to deal with other types of data. Is it? Okay, so that's regarding that we just learned. And what next one try to show here is, so here you create array A, is it array A? And anyway, B is also an array, is it? B is also an array. And here what I try to show is like a NumPy, one of its benefits is arithmetic operation array apply element wise. And it generates a new array. Okay, so be careful here. So in this case, what we show is you do the sign. We already know this part generate an array, is it? And you do arithmetic operation, is it? So you're going to have a new array. So this is a new array, okay? And it's element wise. So this keyword is very useful for NumPy, okay? So even though you don't write any loop or use list comprehension or generator expression, but it automatically give you element by element. Okay, what next one try to show, it's the same. So even for math, if you have two, basically this 2D array, is it 2D array? Okay, and 2D array basically it represents matrix. It represents math matrix. And for math matrix, then you can do what? You can do dot product. Is it? You can also do what? Do cross product. Is it? So over here it shows cross product, and this shows dot product. Is it? So that's why here this is cross product. Okay, and here we have the dot product. Is it? So that's why here we have the matrix operation basically here. It's also element wise. Okay, element wise, because for the matrix it's so you have two matrices, and if you do the multiplication, it's a row times column, is it individual item and the matching, is it, and then do summation, is it? Anyway, so that's how matrix operation. So it's automatically going to apply with element wise, okay? And what next one try to show here, we use that a lot, is it, in our programming language, unitary, is it plus equal, multiplication equal, is it? And when you apply this, hold on, we have need to get admit the student. Then in this case, if we apply to ND array, to NumPy array, it's going to modify existing array. Be careful, not to generate a new array. Okay, so be careful here. So here we have an array A. Is it? A is 2 by 3. Is it 2 by 3? The type is integer with all ones. So you have 1, 1, 1. Is it? And 1, 1, 1. So 2 by 3. So that's for our A. Okay, created. And then you said, okay, multiply by 3. Is it? So if you do something like this, be careful, okay, don't get this confused with general Python multiplication. That's can do the repetition, is it? And here it means you times 3 element wise. Okay, element wise. And also going to change the existing array. That's what here means. And then let's show B plus A, is it? So then B will be changed. If you take a look, that is that, so B is going to be changed. Okay, so that's regarding this part. And what next to try to show? It said some other unary operations. Is it like summation? Is it of all elements? What is that? How that can happen? So here A is a NumPy array, is it? And it's generated with some random number. Okay, it's 2 by 3. Okay, so this is a 2 by 3 array A, is it? And if you do, you just call sum. And if you don't specify, it's 2 by 3. So this is going to sum over all of the numbers. Okay, and here then next, let's see. You specify the axis. Okay, because it's multi-dimensional array, is it? So we have dimension. So this is not just 2D or 3D. Okay, this is n dimension, is it? So you have dimension 1, dimension 2, dimension 3, is it? And for dimension 1, we call it axis is 0. Dimension 2 is axis is 1. Okay, and here it's 2 by 3, is it? So it's something looks like this. It's a two row, 3 column, is it? So first row, second row, first column, second column, third column, is it? And here, it's kind of easy to get confused here, okay? So here it said what? You're going to do summation, axis specify as 0, okay? So you're going to sum as what? If you take a look at the result shows here. So you have 3 columns. So it's 1 by 3 in this case. Initially, you have 2 by 3. Is it? So this 2 is axis is 0. Is it? And that 3 is axis is 1. That's axis 1. And what here implies, you are going to sum what? You are going to sum axis 0. Is it axis 0? So this is axis 0, axis 0. Is it? So you're going to add these 2 numbers, and then next you're going to add these 2 numbers. So that's what you are going to do summation. Okay, you're going to do this kind of a long column. Okay, a long column, but it's, you get the item from whatever you specify the axis. So the result is reduced. Is it reduced whatever that axis? So this axis basically is reduced. Is it? You still have the other dimension. Is it? That's the result. And the same thing, if you do sum, axis is 1. Is it? Axis is 1. You're going to do the sum along. You're going to sum item by item along the row, but from each column. Is it? So that's a group. That's a group. That's why you only have the 2. Is it? So then in this case, you're going to have what? You're going to have a 1 by 2. Is it? The 3 dimension disappear. Basically, it's, we can call it deleted. Is it? It's removed, that dimension. Is it? You keep this dimension. Okay. So that's what the axis mean. Because you may say, oh, normally we think 0 is a row number. Is it? Yeah, it's a row number, but the sum operation, that action, is it? That actions on this group, it's row. Okay, axis is 0, axis is 0. Okay. Okay, so that's, you specify the, if you don't, that's all of the numbers, okay? And we can also call reshape, okay? So if you just do arrange, NP arrange, it's going to have one dimensional number, is it? So the shape is 12. Is it? That's a shape. And then you call reshape. You specify, okay, 3, 4. So first dimension is 3. Second dimension is 4. So that's why you have this is a result array. Is a result array. And what next try to show is this. So B is a 2-dimensional array. So what is this? Is it? What is this? And previously, if you recall, in Python, we also learned indexing and slicing. Is that a slicing? And we know this is regarding slicing. Is it? You specify the starting index, ending index, the range of items. Is it? Along certain dimension you want to get. Indexing is get specific. item, is it? Okay, so here, later on we will also learn that dot, that's regarding first dimension. First dimension here, is it? That's a first dimension, okay? So the first dimension, what dot means is take all. Take all. The second dimension, it's indexing in this case. It's a second one. So it's going to take, that's how you get this result. Get this result. So basically this is the same as this case. So this is slicing. If you don't specify where start, where end, it's take all, as a take all. Okay, so this is a little bit similar like in Python, okay. What next? Let's see. It's still regarding that x-axis. Is it the axis if you specify? So here, this ARR, that's an array. Is it 3x4, two-dimensional array? Is it? And you can also delete some items. Is it from that array? So you can call np delete. Okay, and along which axis? So this is delete along column. Is it the second dimension? You're going to delete items from the second dimension. And which one? The third one. Is it? That's why the first one is kept, second one is kept, but not the third one. As it should be 2, 6, 10. Is it? That's going to, that's deleted. Is it? That's deleted. So we see the result. And what next one try to show over here? It's mean. It can previously we learned sum. It's similar. Is it here? It's try to get mean. Is it? And the mean, the axis. Is it? Axis is 1. Is it? Axis is 1. So you are going to do mean what? So we over here we also have 2, 6, 10. Is it? So you're going to do item by item. Is it? This is where you get the item along the dimension. Is it from each column? Is it from each column? Okay, and then you're going to do what? Do mean. So you need to add all of them together. Is it? Add all of them together and then divide by 4. Is it? That's how you come up with 1.5. Is it? So basically it's 1.5. And then the second row. Is it the same thing? 1 by 1. Is it? And then you divide by 4. That's how you get 5.5. Okay. So that's what this over here axis means. Is it? Axis means. Okay, so basically, is it basically you get rid of the second dimension. You just leave the first dimension. That's the result. Is it? This is 3. Is it? Versus this is 3, 4. The shape. The shape. Is it? So the second dimension, basically after you call the mean, it's gone, as it's deleted, okay. Okay, and the same thing, you can also do sum, you specify the axis, okay. Okay, what next? Try to show universal function. So it's a similar concepts element-wise. Okay, element-wise, like we already see sine, cosine, exponential, is it of those? So it's going to apply on element by element. Okay, so you're going to apply exponential on the first element, on the second element, on the third element. Okay, element by element. And then next, let's see, indexing, slicing, and iterating. Okay, let's take a look, example here. So what is this? This going to generate a 10 elements in the array. Is it? So it's 0, 1, 2, 9. Is it? So that's A, is it? And then you do what? This is arithmetic operation, is it? And then you do cube on that, but on every one of it. Is it on every? That's how you come up with this result. Is it? You cubic that, okay? And then be careful here. Next, let's see. This is our A. That's A, array. Is it 0, 1, 2? Oh, we already cubic. Okay, so that's this array. That's this array. And then you said, did you see this array? What is this? This array generated with this list. Is it? So this array looks like 1, 3, -3. That's what this array is. Is it? So within this existing array, you have this. What does that mean? Okay, this is for indexing. You want to get a specific item. You get the second item, the fourth item, so 0, 1, 2, 3. I want to get the fourth item. -3, who still remembers? Negative number using in indexing. So how about this is third quiz question. What a negative indexing mean?
It's indexing from the back of the list.
Yeah,
So it's
very
counting
good.
backwards.
Yeah, it's counting backward. Is it? Counting backward. So the third, is it? The third. Okay, so be careful. So that's why how you get 343, is it? So that's how we get the result. Okay, be careful. And then if you do something like this, then it's going to work on the copy it cell, is it? It's kind of messy here. So the first element, is it? It's going to be modified, okay? And then what does this mean? Is it? This is slicing, is it? If you recall, that's slicing, is it? So start from the beginning all the way to 6, but not including 6. Count every 2. Then you are going to reassign that specific element to what? To -100. Yes, the first one, the third one, the fifth one, is it? And every 2, you're going to update it. And this, of course, this is indexing. Is it indexing? And then if you take a look, this is kind of weird. This is 1 dimension. We don't have 2 dimensions, is it? So this is just equivalent to you do the indexing. Okay, similar if you do something like this. Oh, I'm sorry, that's index, but this is not indexing. This means you slicing with every 1 step. So basically you get every item, is it? You want to get all the items. And you can do this. Is it? And this is also indicing, but the step here is negative. That's basically its reverse. That's how you get to the reversing result. Okay, so this is similar as in the list. What next try to show is this a multi-dimension can have 1 index per axis. Yeah, we already kind of explained the concept, but let's take a look. What does this specific function mean? This is specific from function, is it? So it does some functionality, so the function can pass in, okay, with NumPy. And this is kind of like you specify, like a coordinate. So it's going to kind of generate new coordinates as X, Y, and Z. So Z will from Y or from this F, calculated result, is it? Based on, so this is going to generate a 5 by 4 dimensional data, is it? So 5, 4 shape. So the data, this array's shape is going to 5, 4, is it? And each of the number, is it? It's going to be generated with the X and the Y value. The X value is going to from 0 to 4, is it? Because it's from 0, so here specify 5, is it? And the Y value is going to be from 0 to 3, okay? And then you calculate this Z result, you will get this result, okay? So that's what this function does, okay? From function. Okay, and then you can also do lambda, as we learned that. Okay, once we have this, so anyway, B is an array. So this is a 2D array. The shape is 5, 4. That's the shape. Is it? And what does this mean? Is it? What does this mean? That means regarding first dimension, we do what? Do slicing. Slicing from where to where? Everybody. Is it? Everybody. And second dimension, you're going to do what? Just a single number, indexing. Is it? Indexing, what is that? The second one. Is it? That's how you come up with this result. Okay, with this result. And that's for this indexing. And then next, let's see here. For this, what does this mean? Is it has a comma, be careful, okay, separate. So that's regarding first dimension, second dimension. So for the first dimension, it's going to do what? Slicing. So first dimension, slicing. Second dimension, we also have colon, so it's also slicing. Is it? First dimension is a long row. It's from the second to the third. Is it? So you're going to have second to the third. And the second dimension, you're going to include everybody. So that's how we get this result, okay? So it's quite useful, is it? With slicing and indexing, you can get a range of number. Is it a range of number? Okay, and then what is this here? Is it? It's 2 dimension. You didn't specify second dimension. Then basically that means second dimension, you are going to do slicing with everyone. Is it? And this negative is count from the, so for the first dimension, you're going to count from the last to the first. Is it? That's how you come with this result, okay? So that's what this part means. And next, let's see the dot, okay? So previous we kind of see dot, is it? So over here, let's see. Be very, very careful here. You have 3 brackets, 3 level brackets. So this is not a 2D array anymore, okay? This is a 3-dimensional, okay? So let's take a look first. So this is the outermost brackets, is it? And within it, you have this second level of dimension and separated with comma. Is it? How many we have? We have 2. Is it? We have 2. So this basically is the first dimension, okay? Then the second within this blue one, what I have 2 red one. Is it? Within each of it, you have the same pattern. Is it? So that's the second dimension. Okay, second dimension. And then next, let's see. And within the second dimension, you have each individual number. Is it? So that's a third dimension. So the shape Then in this case, 2 by 2 by 3. Is it 2 by 2 by 3? Okay, and what does this mean then? This means you specify the first dimension is the second item. Second dimension, you're going to find the second item. The third dimension is going to be the last one. So that's how the result. So this is purely indexing, is it? So that's how you got 113. Is it 113? And then let's take a look at this. And we just mentioned the first dimension. The second dimension we didn't mention. Third dimension we just used dot, dot, dot. So that this is going to be the same as what you do what? You do second dimension, third dimension with the slicing, including everyone. Is it including? So the first dimension is the second item, okay, here. So that means you get this region, is it with this region? Okay, so that's what this part means. And then next, let's see. Then what this means? This means only the last dimension. Is it? You take the third one. The first two dimensions, I'm going to take everybody. Is it? Okay, so let's take a look. So the last dimension, that's the last dimension. Is it? The first two dimensions, everybody. Is it? So that means you're going to get all of the items here. Is it? All of the items here. But the result is what? The result then is going to be a 2 by 2. So the shape is reduced. Is it? It's reduced. Even though 2 and 13, 102, 113, they come from different brackets, but after you do the slicing, they are reformed as a new array with this shape, okay, with this shape. So be careful here. Okay, and it's 11:50, so we get to the time.